definition except for one part. Yep. Today is difference instead of sum. So the equation looks almost identical. X minus h quantity squared over a squared. And then it's a minus y minus k quantity squared over b squared is equal to 1. So notice you have difference, you have subtraction there. It's the only thing that makes it different. It does result in a very different shape and different characteristics. But in terms of the equation, just a minus, that's it. You good with that? Okay, so let's talk about what a hyperbola looks like. The first thing we do is we identify the center of the hyperbola, okay, and that's located at HK, just like you would think. I'm going to put it at 0, 0 right for now. And then what I do is I look at the values under X and Y, and I make a box. Make an initial box is the best way to help me with the structure for my graph of my hyperbolas. So as I make my box, anybody want to guess how many units I go in the X direction? A. Just like yesterday, we used A and B to kind of make the stretch for the ellipse. Remember that? Today we're going to use A and B to make the box. So we're going to go A units to the right. And anybody want to guess how many units I move vertically? B. So if I move A units to the right in each direction and B units up and down in each direction, I then make a box for that. Okay. The box is not the graph. The box helps me construct the graph. I'm going to go ahead and draw the asymptotes that go through the box. So hyperbolas have asymptotes. Those are imaginary lines that the graph approaches. Okay? They're not actually the graph. The only other thing you do now in order to construct the graph is you place the vertices on the sides of the box. And then the shape of the hyperbola is kind of like a parabola. It heads off and it follows those asymptotes off to the side. It looks like such. And that's a hyperbola. And from that, we can generate a few different elements of these characteristics. Number one, the vertices. The vertices, I move A units from the center. Is that going to change the H value or the K value of the center? H. So the vertices will be located at H plus or minus A, and then the K value. The length of the transverse axis. The transverse axis is the distance between the two vertices. What's the distance between the two vertices? Twice the A value. The asymptotes. In order to write an equation for a line, you need two things. You need slope and you need a point. What is the point that the asymptotes are always going to travel through? Not the vertices, but so the C rhymes with enter. Center, yeah, it goes through the center, right? And so HK is going to be our point that we will use for our asymptotes. Both of them will always go through that. And then the slope is going to be equal to the rise and the run of the box. What's the rise and the run of the box? B over A. And notice how one is positive and one is negative, so we got plus or minus B over A. And then finally, the foci, those are these things that sit on the inside of the hyperbola shapes. They sit over there. Anybody want to guess how many units from the center the foci sit? Yes. C, yeah, C units from yesterday, yeah. So I said C units from the center, so it's going to be H plus or minus C, and then your K value. Now you need to know how to find C. Anybody want to take a guess? Yesterday was minus, wasn't it? Today's a plus. There you go. Piece of cake, upside down. Watch how quick these are to graph, okay? Sketch a graph of this guy, okay? I'm going to move it over a little bit. We're going to put the characteristics over here. Stop doing that. There we go. So we're going to do the center. We're going to do the vertices. We're going to do the length of the transverse axis. Do the foci. And we're going to do the asymptotes. Asymptotes is a Greek word. It can be pronounced asymptote or asymptote, either way. It's more common these days to say asymptote. But when I first started teaching, the students made fun of me because I said asymptote. They're like, it's not asymptote, it's asymptote. Okay. I thought we'd be debating about like music we liked or something like that, but you know, whatever. Center, what do you got? 0, 0. Once I get the center, I go to make my box. My box is I make using these values. How many units do I go in the x direction? 2. How many units do I go in the y direction? 5. I then make my box. And I really like making the box. It's not something that the book teaches to do, but I just think it's the best way to help people organize their work. I know that's what connects for me. So make the box. There I go. What should I do next? Yeah, draw my asymptotes. Notice how I'm not filling out any of this information over here, am I? I'm just making the graph. Just hanging it out, making the graph, having some fun. It's a light day in the mathematics world, just drawing some hyperbolas. We already said our center was 0, 0, and now it's time to start to make our shape. Do I put the shape where? On the sides, yeah, these vertices. And notice how wide of a hyperbola this is. It has a very wide and kind of broad shape to it. But they're all unique in their own way. You don't say one is better than the other. It's kind of like when people ask you, do you have a favorite child? Of course I have a favorite child. You just don't say which one it is. Okay, vertices, location. Plus or minus 2 and 0. Excellent. The length of the transverse axis, the distance between the 2 points is 4. Now I determine the foci. In order to determine the foci, I need to find the value of C. To find C, I take a squared plus b squared. Doesn't matter which one is A or B, because you're going to add them together, okay? So before, like yesterday, A was which one, the bigger one or smaller one? A was the bigger one. Now it doesn't matter because you're going to add them together, okay? So just add them together, you get C squared is equal to 29. So C is equal to the square root of 29. So the square root of 29, that's about 5.5. So as I plot that, I need to go 5.5 units in each direction. So the location of the foci are plus or minus the root of 29 in each direction, and then 0. About 5.5. Okay, for the asymptotes, I need 2 things. What 2 things do I need for the asymptotes? I need slope and point on the line. And Aaron always said the point on the line is center. So I'm going to say the point is 0, 0. And the slope is plus or minus. I need the rise over the run. Look at my box. What does my box say for rise over run? 5 over 2. So I'm going to write the equation for this line. Y minus y1 is equal to m times x minus x1. That's how I write an equation for a line. Your y1 value is 0, so we just have y equals. Your slope is plus or minus 5 halves. And since the x1 value is 0, I just have x. And that's the equation for your line. What do you think? Not too bad? Pretty simple? Good. What up, G? Yeah. So as you plot them, notice they are on the x-axis. We went horizontally. See that? We moved horizontally this way, so they're sitting, horizontally from the center. So we just moved with the 29 square 29 units horizontally. If we moved up or down, then we change that value. But since we moved side to side, we changed this value. Yes. The center. Well, the hyperbola opened up side to side. So let's talk about that up and down piece right now. So Caitlin led us into the vertical hyperbola. The vertical hyperbola has the equation of y minus k quantity squared over a squared minus x minus h quantity squared over b squared is equal to 1. So what's different about that equation compared to the other one? Yeah, they are switched, and it matters because if x is positive, it opens side to side. If y is positive, it opens up and down. That's the difference. We don't care which one's bigger. We don't care about A or B, which one's bigger. We just always say A is first and B is second, okay? But we don't care which one's bigger. We just care which one's positive, which one's negative. So in this situation, as we kind of mark off our hyperbola, we'll continue to go. We'll plot our center, and then we'll make our box. And when we make our box, how many units do we go in the y direction? A units in the y direction now. So we're going to go A units in the y direction, and we'll go B units in the x direction. Because now A is under the y value, and B is under the x. And as I mark off those distances, I can make my box. And I draw those handy-dandy asymptotes. And once I have my box and the asymptotes, I can then construct the hyperbola. I place the vertices now on the top and bottom of the box because, again, the y value is positive. And I have my shape. Okay, the vertices. From the center, I move up and down how many units? A units. Does that change the x value or the y value of the center? The y. So therefore, it will be h, and it'll be k plus or minus a. The length of the transverse axis is the distance from the vertice to the vertice, which is 2a. In order to determine the asymptotes, we need a slope and we need a point. Slope and point. The point is still hk because it goes through the center. What is the slope in this situation? Plus or minus a over b now. And the foci, they do sit C units on the inside, C units from that center. So that value is C. That changes the Y value of the center, so we'll be at H, and they'll be at K plus or minus C. That's what we got. So again, I can't emphasize enough, you get to put together your notes for the test, one page front and back. If you want to like cut these out, put them on there. If you want to rewrite them, can't put examples, but you get to put notes. I don't know how this stuff makes sense to each person. You got to decide how that works for you. If you want to use the page I give you on the back, you can do that. Some people don't like that. That's up to you. So, sure, yep. Some people just clip that off. If you want to do that, go ahead. We're going to graph this guy. I don't know how to graph it yet. What should I do first? So it's equal to, yes, all the hyperbola and the ellipses must be equal to 1, so I divide by 36. I get x squared over 9 minus y squared over 4 is equal to 1. I have the center. I have the vertices. I have the length of the transverse axis. I have the foci. And I have the asymptotes. What I would like you to do right now is take about a minute and a half, and I would like you to be able to see if you can draw the graph. Don't worry about filling out the rest of this, but see if you can draw the graph on your own. Make your box, draw your asymptotes, see if you can get your graph. Go. Okay, I drew my box. It was 2 units high, 3 units long in each direction. Did you put the shapes on the top and bottom or side to side? Yeah, side to side, because the x is positive. So note which one is positive. Did I catch anybody? Anybody put them on the top and bottom? Yep. And notice we were just used to seeing it under the top and bottom. So you just assumed, right? You got to check to see which one's positive. Okay. Great. So we know the center is 0, 0. The vertices are on the side. So what's the location of the vertices? Yep, 3, 0 and negative 3, 0. Or you can just write plus or minus 3, 0. The length of the transverse axis, that's the distance between the two, which is 6. In order to determine the foci, I need to find C. And C squared is equal to A squared plus B squared. So if we take A squared plus B squared, we get 9 plus 4 is C squared. So therefore, C is equal to square root of 13 is equal to C. So, you know, square root of 9 is 3, square root of 16 is 4, so it's going to be about 3.5. If I just mark off 3 and then 4 here, 4 there, I notice that 3.5 is, there we go, put a point right there and point right there. That's about where the foci are. So from the center, we change the x value or the y value. The x value, we moved the root of 13 one way and the root of 13 the other way. So plus or minus root of 13, 0. Yeah? Okay, asymptote, I need 2 things. What do I need? So I'll put a point. The point is 0, 0. And the slope, plus or minus 2 over 3. So if you write y minus y1 is equal to m times x minus x1, just notice that we're plugging in 0 and 0 for the x and the y. You get y is equal to plus or minus 2/3 x. Yes. So I plug this 0 right here in for the x sub 1. I plug this 0 right here into the y sub 1. And that's why those go away. There's no shift centered on 0, 0. Not too bad? Okay, last one. Flip it over. Good job. Okay, this is where it should all come together. Okay, I kind of did one for you. We did one together. Now this one should all kind of make sense. Okay. Letter B. What do you want to do first? Excellent. Divide by 36. I have y. Whoop, that was an x. Very similar to each other if you think about it. Need to start by determining the center. What's the center? The shift for x is 1. The shift for y is, see how it's different when it's like that? I thought you had a question. Okay, I'm going to move over 1 and down 2. And I'm going to make my box. How many units do I go in the y direction? 6. So I'm at 2 right now, and I got to go down 6. So 3, 4, 5, 6, 7, 8. And up 6. So 1, 2, 3, 4, 5, 6. That'll be all the way up to 4. How many units do I go in the x direction? 2. Hopefully my dot is in the center of the box. This is supposed to be the center of everything. I will draw my asymptotes. And I'm ready to place the vertices. Do I place the vertices on the top or on the bottom? Oh, I said on the top or the bottom. Yeah. Do I put it on the top or bottom or side to side? Why do they go on top and bottom, not side to side? Because the y value is positive. So I need to identify the location of the vertices. What is the x value for the vertices? It is 1, because that does not change from the center, does it? It is only the movement of the y coordinate. So from -2, I moved up 6 to get to 4, and I moved down 6 to get to -8. The length of the transverse axis is the distance from the vertice to the vertice, which is, it is 12 units. It's 6 in each direction. To find the foci, I must calculate c squared, so, or c. And so I have a squared, which is 36, plus b squared, which is 4, and I get c squared, or 40 is equal to c squared. How can you simplify the root of 40? 2 roots of 10. Now, I happen to know that 2 roots of 10, like the square root of 10, that, square root of 9 is 3, so square root of 10 is probably 3.1. Multiplied by 2, we got 6.2. So if I move up 6.2 units, be right about there, and down 6.2 units. So is the 2 roots of 10, is that going to change my x value or my y value? So I've got 1, and I got negative 2 plus or minus 2 roots of 10. That's the location of your foci. And finally, for the asymptote, I need 2 things. I need my point. What is my point in this situation? It's not 0, 0. It is 1, negative 2. And then what is the slope? Rise of 6, run of 2, so slope is 3. So you write your equations for the lines. It is y minus y1, or y plus 2, is equal to the slope times x minus 1. And you can just leave it in that form. That's all she wrote. Good job. Normally tomorrow would be a work day to work on these 3 assignments before we go on the next one. But I can't really do a work day tomorrow because then we would miss instruction on Friday, right? And on Monday, and on Tuesday, and on Thursday. So that doesn't work. So last day tomorrow for instruction. Good job. I can even get you guys a study guide in hand. You'll have time to work. So, all right. Good job. Get outside. Take a walk.